Today question is that if a raised to power n, b raised to power n, and a raised to power n minus 1, b raised to power n minus 1. Uh, this is the GM between the a and b. Then we have to find out the value of n. And how we are going to find out the value of n? First, we understood what is the meaning of GM. So, GM means geometric means. So, geometric means if a and b are two numbers in which one GM is exists. So the GM is equals to root of AB. We know that by definition of geometric. So now the question arises that how we can find out the value of n if this is the geometric number. A raised to power n plus b raised to power n, a raised to power n minus n, b raised to power n minus 1. So we know that the GM between A and B is known as by root of AB. So according to our question is that A raised to power n plus B raised to power n divided by A raised to power n plus B raised to power n minus 1 must be equals to root of AB. Because this is also in between A and B, and this one is also in between A and B numbers. So now we have to apply the rules and the method or exponential rules. So to find out the value of n. So the first step is that we have to remove the square root. And this is the only way we can do that. We have to square it both sides. The first step is that we have to squaring both sides. And how we are going to squaring it? So this is equals to a raised to power n plus b raised to power n divided by a raised to power n minus 1, b raised to power n minus 1 whole square and root ab whole square. So when we are going to square both sides, so now we got it a raised to power n plus b raised to power n whole square divided by a raised to power n minus 1 plus b raised to power n minus 1 whole square. And this square root and the squares are going to be cancelled out. So we got the a. And what rule we are going to apply here? Exponent rule. Exponent rule is saying that if a by b is raised to power n, then the power is going to be distributed both of them. Okay. And why the square root is subtracting this? So we know that AB is equals to half squares because square root is also written as half, and this 2 and 2 are going to be cancelled out by using the exponent rule. So now this is the simplified form we have getted. Now we have to find out the value of n by using this relation. So the next step is that we using the cross multiplication. And how it is going to be used a raised to power n minus 1 plus b raised to power n minus 1 square. Because this part is in the numerator of this part, so it will go this side by cross multiply and it's going to be times 2 that a. Now we know that the formula of a plus b whole square, that is a square plus 2ab plus b square. So we are going to use this formula in these two brackets. So this is equals to a raised to power n square plus 2 a raised to power n b raised to power n plus b raised to power n whole square. This is equals to a raised to power n minus 1 whole square plus 2 a raised to power n minus 1 b raised to power n minus 1 plus b raised to power n minus 1 whole square. So we just applied that formula of a plus b whole square. Now by exponent rule, the next exponent rule is that a raised to power m raised to power n. So this is equals to a raised to power m times n. So we are going to apply this. So this is equals to a raised to power 2n plus 2 raised to power 2a raised to power n b raised to power n plus b raised to power 2n. Okay. So now this is AB. Now we are simplify this. This is equals to a raised to power 2n minus 1. This is 2 is going to be multiplied with n minus 1. And 2a raised to power n minus 1, b raised to power n minus 1 plus b raised to power 2n minus 1. So this is our simplified form. So now we are going to further simplify it. So how we are going to simplify it? That a raised to power 2n plus 2 raised to power a raised to power n b raised to power n plus b raised to power 2, and this AB is going to multiply with this. So first I am using the one more step here, a raised to power 2 and minus 2. Just multiply this 2 inside the bracket and distribute it. So this is equals to 2 raised to power n minus 1 b raised to power n minus 1 plus b raised to power 2 and minus 2. I hope this step is clear. Now we are going to another simplification form, that 2 raised to power a raised to power n b raised to power n plus b raised to power 2n. Now AB is going to multiply inside it. Now a, what rule we are going to use, that a raised to power m plus a raised to power n times, then this is equals to a raised to power m plus n. If bases are same, then powers are going to be added. So look this, this is going to be a raised to power 2n minus 2 plus 1 and multiply b. Because this a raised to power is 1, this is going to be multiply this, then we can write this. So similarly, 2 raised to power a raised to power n minus 1 plus 1, b raised to power n minus 1 plus 1, because this AB is going to multiply with this. And last, a b raised to power 2n minus 2 plus 1. Now, the left hand is still same, so I am just using the, we'll simplify this step. A raised to power 2n minus 1 b plus this become a raised to power n and b raised to power n plus a b 2 raised to power n minus 1. So I just write this also, because some part is going to be cancelled out here. So look at this. This part is same sign and this part is the same sign, positive, positive. So then it's going to be cancelled out if we are taking one part to the right or left side. So now we got it. A raised to power 2n plus b raised to power 2n and is equals to a 2n minus 1 b plus ab 2n minus 1. Now how we are going to simplify it? Now we have to either one term we have to take, look at this, I am just taking this term to left side. So this is become a raised to power 2n minus 1 b. And similarly, the other part, that b raised to power 2n is going to be here. Okay, so I just took this b raised to power 2n to other side. This is a positive sign, then it will become negative. And similarly, this is the positive sign, then it will become negative. Now, we have to write some more field simplification, so better understanding. So I can write this as a raised to power minus 1 is equals to a b raised to power 2n and b raised to power minus 1 minus b raised to power 2n. Which rule I am going to apply here? This a raised to power m plus n, then this is equals to a raised to power m times a raised to power n. So we can also break the part. So now the common is a raised to power 2n. So the remaining one is a b by a. Why b by a? Because a raised to power minus 1 is 1 by a. Then this is equals to, now b raised to power 2n is going to common out, and this is a by b minus 1. So now we have to take the LCM in this side. This is a, then this is become a minus b, then b raised to power 2n, then this is equals to a minus b by b. So now we can easily simplify it. How? Look at this part, a minus b and a minus b are on the numerator of each side. So that can be cancelled out very easily. So what we have remaining now? 2 raised to power n by a is equals to b raised to power 2n by. So I can also write this as this one is a by b by, because this a is the numerator denominator, then this can be transferred here in the numerator, and this is the in the numerator, then it can be transferred here in the denominator part by cross multiplication. So now I can say that a by b raised to power 2n and a by b raised to power 1. Now the bases are same. Bases are same means a raised to power n is equal to a raised to power n. Then we can say that n is equals to n. So similarly, the way is that 2 raised to power n is equals to 1. So we got at n is equals to 1 by 2. So the value of n is equals to half. If the question is that a raised to power n by b raised to power n is I am just marking here. This part is the GM, between the number a and b. Then the value of n is must be half. And how can we verify now this? Now I am going to also verify. Look at this, how my answer is correct or incorrect. And now originally it says that a raised to power n, b raised to power n divided by a raised to power, I can cross check it, a raised to power n minus 1 and n minus 1 and b raised to power n minus 1. So let me check. I am just substituting n is equals to half. A raised to power half plus b raised to power half divided by a raised to power half minus 1 plus b raised to power half minus 1. So let's be simplified. So a raised to power is square root a, square root b. Okay, so this is become, I think, a raised to power negative half and b raised to power negative half. So we can say that root of a plus root of b divided by 1 by root of a plus 1 by root of b. This is root a. So I can take the LCM in the denominator simplification. So this becomes root b plus root a divided by root a multiply root b, a root a times root b. So this is going to be look like this. I have to erase it. Root a plus root b divided by root a plus root b times root a times root b. So this was going to be cancelled out and we got it root of AB because this can be on each side multiplied. So this is the originally we know that if GM is in between the number of A and B, then we get GM is equal to root AB. So our calculation is absolutely correct and we got the value of n equals to half. I hope you understood this and we use a lot of exponent rules and all the calculation for this to find out. Thank you.